Well, I have to whisper because the baby just fell asleep, but it's freezing cold outside and I'm playing with my telescope. Thank God for the NASA hoodie. So I just want to show you something quite incredible. I've got the telescope pointed up towards the Trifid Nebula at the moment, and looking at that part of the sky with the naked eye, you cannot see any stars at all. Now I've got the camera taking a 17.2 millisecond exposure there, and as you can see, we don't see any stars. So I'm just going to increase that, and you will slowly see the stars beginning to appear. It's now about 1.5 second exposure. We'll increase that to 5 seconds. It's now 4.9 seconds on the exposure. And we can see a lot more stars. We'll put that up to 10 seconds. And you can see the green bar down there is just counting off the exposure. We can see a lot more stars. Put that up to 20 seconds. 21.7 seconds. And there you can see the Trifid Nebula, and that's in a part of the sky that just looks completely black to the naked eye. So there's the telescope doing its thing on the Celestron AVX mount, and I have it pointed up towards the position where the geostationary satellites are. It's a star that goes by the designation of SAO 121170, which I'll show you in the planetarium software shortly. And this is my iPad with a number of astronomy programs, and my personal favourite is Sky Safari. And this is the star I just mentioned, SAO 121170, and you can see the other catalogue numbers there too. If we centre on that star, you will notice that it is directly in line with the line of geostationary satellites. So when the telescope is tracking that star, we will see satellites going past. What you can also see is a very distinctive constellation pattern there, and this is what it actually looks like from the telescope. You can see that distinctive shape. And you can see the planetarium software is showing us that we have another satellite moving into position near that star. So with any luck, we'll see it in the actual footage from the telescope. And there you can see it. Exactly as the planetarium software predicts. Now this is taking 23-second exposures. And there's the satellite. Exactly as predicted. And being in Sydney, Australia, I'm 34 degrees south latitude, and that is just over 2,000 nautical miles south of the equator. And from this position, the line of geostationary satellites appears north of the celestial equator. If I was located on the Earth's equator, those satellites would be perfectly in line with the celestial equator. If I was in the northern hemisphere, the line of geostationary satellites would appear south of the celestial equator. You'd see that very clearly in the software. So I plan to leave that time-lapse running for the next few hours, but I'll just leave you with some footage taken about a month ago, looking up at the same part of the sky, and you will see just how many satellites pass by that star in the space of a few hours. Now, a question for flat earthers. This is an equatorial mount, correctly polar aligned for Sydney, Australia, 34 degrees south latitude, well south of the Tropic of Capricorn. It is moving on a single axis only and at a steady rate, and yet every star in the frame is being held stationary during the time lapse. How is that possible if the sky is rotating above a flat Earth? Quite simply, it is not. And when flat earthers finally figure out the geometry of how an equatorial mount works, they will realize why the Earth cannot be flat.